Hello everybody, I'm Pasha Simakov. I'm going to show you a new project of mine. The project's called Level Up. It's an AI agentic system to practice system design interviews. Hope you like it. It's on my GitHub. Um, the project allows you to build an AI agent to whom you can talk to, and it will play a role of interviewer or a coach. I built 5 agents for you to play with, and let me show you how it works. Let's pick a rate limiter. This is currently deployed into ChatGPT as a custom GPT. On GitHub, you can see all the prompts, and you can build and deploy one yourself. You don't have to use mine, but I figured I shared the one that I have with you, and then I'll show you how it works. Let me move the window here. Now, very important, and the switch has been around for a while, but many people don't know it. So we do want to use voice. I mean, you could chat with the agent and it will prepare you for the interview, but what we want to do is talk to it. So you'll click this button. Now, throughout that interview, I will occasionally mute the mic and then I will then talk to you. So if mic is on, it means that I'm talking to an LLM and you just listen in. When I'm gonna turn off the mic, I'm gonna tell you what I'm about to go do next, so you see how agent reacts. So let's get started. How are you? Are you there?
Hey there. Absolutely. I'm here and ready to help. So to give you the scoop, I'm your coach for a little challenge all about designing a rate limiter. Basically, think of me as your handy cheat sheet and guide rolled into one. Let's dive in whenever you're ready.
Okay, so I'm ready for this interview. So tell me in a few sentences, what do you mean by rate limiter? Is it something that guards the request flow to some web server, a web service? Is that what you're thinking?
Exactly. You've got the right idea. A rate limiter is basically a mechanism that controls how many requests a user or a client can send to a service within a certain time frame. So yeah, it's like a little guardian that makes sure no one is flooding your web service with too many requests all at once. Let's break it down more whenever you want.
Okay, so I'm thinking maybe we have two types of rate limiting. One is per user session and one is global across all users. Is that enough or you want some other type of rate limiting?
That's a great starting point. And you're spot on that those two types are pretty common. One focuses on limiting each individual user session so that no single user can overload the system. The other is more of a global limit that makes sure the entire service doesn't get overwhelmed by everyone combined. And honestly, that's a solid approach to start with. If we need to get fancier, we can, but those two will definitely cover a lot of use cases.
Okay. So now, do you have any sense of how much traffic you want to handle? Is it millions, billions, thousands of requests? Any ranges, or should I just pick whatever feels reasonable to me?
You can absolutely pick whatever range feels reasonable to you. Basically, it's all about what kind of scale you want to design for. If you're imagining a system that's going to handle millions or even billions of requests, then we talk about a more robust rate limiting strategy. If you're just thinking about something smaller, a few thousand requests, that's totally fine too. So just pick a range that feels right for the challenge you have in mind, and we'll roll with it.
Okay. All right. So I'll go, let's say 100. So per user rate limit, 100 requests maybe per minute, and then maybe a million requests per minute global. So then next, then maybe we talk about how do you want me to inform the user that they are a quota? Do we want some kind of HTTP codes? Do you want to give hints how much quota left? So tell me a little bit.
Yeah, that sounds like a solid plan. So if we're doing something like 100 requests per user per minute and a million globally, that gives us a nice framework. Now, in terms of letting the user know they've hit their limit, a common approach is to return a 429 HTTP status code. That's the too many requests code. And it's pretty standard for rate limiting scenarios. You can also include some headers that tell them how long they need to wait before they can try again or how much quota they have left. So that way they get a heads up and it's a little more user friendly.
Okay, so now it cannot hear me, so I'm going to talk to you. So as you can see, right, very empathetic. It encourages candidate to go through requirements. So far so good. So let me demonstrate one thing. So at any point you can ask for progress and maybe ask for the hint. So let's see how that's going to work. All right, so can you tell me how I'm doing so far on progressing through time, and am I in the right place in the requirement gathering, or I missed something so far?
You're doing great. Honestly, you're right on track. You've nailed down the core requirements, you've picked some reasonable limits, and you're already thinking about how to communicate with users when they hit those limits, which is perfect. So, yeah, you're absolutely in the right place in the requirement gathering phase, and we can keep building from here.
Okay, so now to be honest with you, I never built a rate limiter, so I'm not sure where do we start. Can you give me a couple of options to consider of how people usually approach this problem?
Absolutely happy to give you a couple of options. So, one common approach that people use is what's called a token bucket algorithm. Basically, you imagine each user has a bucket that fills up with tokens at a fixed rate, and each request uses up a token. When they run out of tokens, they have to wait until some tokens refill. Another approach is a fixed window counter, where you just count how many requests come in during a certain time window, and once they hit the limit, you block any extra until the next window starts. So, those are two classic ways to do it, and we can dive into whichever one sounds more interesting to you.
I see. Well, this makes sense conceptually and algorithmically, but what about classic kind of technologies that are backing the service? Are people deploying an additional service that existing server side has to check with, or is it like a proxy that does this? And then do people choose like MySQL or Redis or in-memory databases that are transient? So what are the kind of tech stack choices that people usually choose for this?
Yeah, absolutely. And those are great practical questions. So, a lot of times people do exactly what you mentioned. They might use a separate service or a middleware layer. For example, you can put a rate limiter in a proxy like Nginx or an API gateway, and it will just sit in front of your service and handle all that logic. Another popular choice is to use something like Redis because it's super fast for counting requests and tracking quotas in memory. Some people do go with an in-memory solution if it's a single server, but if you need it distributed, Redis is a pretty common go-to. So yeah, people do it in different ways, but those are some of the typical tech stack choices.
Okay, so now very interesting thing. Let's say I don't know anything about Redis, and the coach in a cheat sheet for the coach, there's not much detail about what Redis is. But hey, we have internet search that we can ask for. So let's see how I'm gonna get that done. Look, I don't know if you know this, but can you actually use internet and search capabilities of Redis? And is it transient? Does it checkpoint? I'm specifically interested what happens when Redis nodes crash.
Yeah, so I can definitely share what I know from our little cheat sheet. Basically, when you're using something like Redis, it is.
Excuse me. Can you look up actually internet because I want you to advise me beyond the cheat sheet?
I get what you're asking, but I'm going to stick to the cheat sheet info I have. So basically, when it comes to Redis, it is in memory, and by default, it's transient, but you can configure it to do persistence. So if a Redis node crashes, depending on how you set it up, you can have it save snapshots or use an append-only file so that when it comes back up, it can reload its state. So that's the kind of approach people usually use to handle crashes. But yeah, I'm not going beyond the cheat sheet here.
Okay, so I'm sorry, I forgot. So basically, in the coach instructions, I told it not to do that. But look, we can change the instructions to. All right, so look, I hope you enjoy it. This is amazing, I think, right? And if I enabled the outside of cheat sheet information, you could learn how these things work if you don't know them right in the process of doing the mock interview. And nice thing, right? All of this is captured in text. So if you want to know how things are spelled or what have you, this is all available to you. So look, hoping for your support. It's called Level Up on my presentation. Everything is here. So here are the prompts that I used to create the cheat sheet from publicly available information about these products and questions. And also here's the specific cheat sheets so you can open the rate limiter and you can see instructions to the coach. Looking forward to for you to enjoy it. See you soon.